So in this question asks us to name the theorem or postulate, which allows us to conclude that the angles A and C are congruent. That one is the isosceles triangle theorem. So again, the isosceles triangle theorem says if two sides are congruent, then two angles are congruent. The converse says if two angles are congruent, then two sides are congruent. If the measure of angle B is 34 degrees, what's the measure of angle A? So if we know this is 34, we know there's two congruent sides, so that means there's going to be two congruent angles. So we'll go ahead and call these x. So that means 34 plus x should add up to 180 because those are the three angles inside the triangle. So we add those together to get 2x, subtract the 34, get 146, which means that the measure of angle A is going to be 73 degrees. What best describes the following triangle? Well, before we can figure that out, we actually need to do 12b first. We need to add up all these angles and find out what x is to figure out what the angles are. So we'll take 3x plus 3x plus 2x plus 20 equals 180 degrees. 3 plus 3 plus 2 is 8x equals 160, which means that x is 20. Plugging it back in, 3x is going to be 60, and 2 times 20 plus 20 is also going to be 60. So that means all three of these angles are 60 degrees, which means this triangle is both equilateral and isosceles. Isosceles means it has to have at least two sides and angles congruent. Equilateral, though, then allows it to have all angles congruent. So it is both equilateral and isosceles. 13, triangle ABC has side lengths of 13 centimeters, 16 centimeters, and 21 centimeters. The 13 centimeter side is opposite angle A, 16 centimeter side is opposite angle C. What is the angle with the greatest measure? So, always best to draw a picture. Triangle A, B, C. The 13 centimeter side is opposite angle A. So this is where 13 is. 16 is across from angle C, which means the remaining side 21 is across from B. So what is the angle with the greatest measure? Well, it's the angle across from the biggest side. So the biggest side is 21. Angle across there would be angle B. For what value of x is triangle DEF an isosceles triangle? Well, if we want it to be isosceles, we probably want to make sure these two angles are congruent. So we set them equal to each other. 5x plus 11 is equal to 4x plus 2, which makes x equal to 13. What's the measure of angle E? Well, we need to find out what D and F are first. So we'll plug it in. 4 times 13 plus 2 will get us 54 degrees. So that means angle E plus 54 equals 180, since we already have those two congruent angles. Measure of angle E then will be 72 degrees. Triangle XYZ. Let's go ahead and draw it. Angle X is less than angle Y, which is less than angle Z. So just for ease of use here, angle X is the smallest, so I'm going to call it 1. Angle Y is in the middle, I'll call it 2. Angle Z is the biggest, so I'll call it 3. So if we want to order the side lengths from greatest to least, the greatest side will be across from the greatest angle. The greatest angle is Z, so the side across from that is XY. The next biggest angle is angle Y, so across from that is XZ. And then the smallest angle is angle X. So that means the smallest side is side YZ. Number 16, given two sides of a triangle, what's the name of the theorem that allows one to find the range of possible values for the third side? I said it was the triangle inequality theorem. I think the key on Canvas has a different answer. I think either one would really be acceptable. The triangle has sides 4 centimeters and 21 centimeters. Find the range of values for the missing side. So this is similar to what we did on the front. We'll take 4 plus x as saying x is one of the smaller sides, which means x would need to be bigger than 17. And then we'll take 4 plus 21 bigger than x, assuming x is the largest side. So that means x has to be less than 25. So if we write it as one inequality here, x has to be in between 17 and 25. What additional piece of information do we need to prove the triangle is congruent by HL? So the things we need for HL, we need to know they're right triangles. Then we need to have the hypotenuse is congruent, and we need to have one leg congruent. So looking at these pictures, I see they're both right triangles, so that's good. And then I see they have one leg congruent, so that means we need to prove the hypotenuses are congruent. So the hypotenuses are across from the right angles, so we would need AB to be congruent to FG. We can't just say AB and FG. We specifically need to know that they are congruent, so that the triangles are congruent. So make sure you're doing that. All right, sketch line M parallel to line N with transversal T. Line M, line N, transversal T. Angle 1 and angle 2 are corresponding angles. So I'm going to put angle 1 here, angle 2 here, corresponding. Angle 2 and angle 3 are alternate interior angles. That means angle 3 will be right there. Angle 3 and angle 4 are corresponding angles. So that puts angle 4 right there. And angle 5 forms a linear pair with angle 4. So that gives us actually two options. Angle 5 could be there or there. Measure of angle 1 is 70 degrees. What's the measure of angle 5? So a couple things we could also do here. We could do angle 5 as corresponding angles. It would be right here. And then it would also be corresponding here, as well as those vertical angles, which we know are congruent. So if angle 1 is 70 degrees, angle 1 and angle 5 form a linear pair. They're next to each other. They make a line, so they should add up to 180. So that means angle 5 should be 110 degrees. If you have any other questions, feel free to email me and let me know.